My name is Satish Rao. I'm from the United States. I'm a postdoctoral researcher here at ICFO, Institut de Ciències Fotòniques, and I am studying physics and biology of cancer cells. We use laser spectroscopy to study cancer cells. In this project here, I'm imaging cancer cells in the microscope here and using a laser to move around and probe the distribution of a drug that we inserted into the cell. This particular cell comes from brain tumor cells from humans, which we get from a local hospital here in Barcelona through a collaboration. And so the idea is to track in real time what the drug does in the cell as we excite it with the laser. And so we can decide how effective a certain drug is in terms of curing the tumor. The Raman spectroscopy essentially uses a laser light to take information about the vibrations of the chemical bonds of any type of molecule. So anything on this planet has a Raman spectrum. And it's almost like a fingerprint, a thumbprint of that particular molecule. So each cell has its own fingerprint or Raman spectrum that we can use to identify changes of the state of the cell when we insert a drug inside it. Inserting the drug into the cell and watching as the Raman spectrum for this particular chemical decreases down to nothing, and then we know the drug has done something to the cell. Now we are getting to the point where we can study cells by themselves on an individual basis. As you can see here, this is an image of just one cancer cell, of maybe 1 million or 100 million that could be in the human body for a sick person. And so getting it down to this molecular level allows you to study and understand much more information than we ever could before. And it's all because of the use of lasers and different spectroscopy techniques that allows us to essentially open up an individual cell by itself and study what's inside it. The technique was originally not meant to be used for biology. It was used for other things. In fact, in my PhD studies, I used this technique to study semiconductor nanoparticles for the use of computer chips. And so when I came to ICFO, my skills were with the technique, but I am now applying it to something different, which is biology. I never thought when I started studying physics that I would be involved in something like cancer research. That usually is meant for biologists. And so that's what's most exciting right now, is to be involved in something that's that helpful. In terms of how I feel a personal connection, I think that will come when the results come. If the project were to be successful, I think then I'd really get a sense of what I've been able to accomplish. Most of the ways that are done to approach someone for a job is simply email professors. In the scientific community, it's not very formal as it would be with a company. So I just wrote an email to my boss and said, I'm interested in working in your group, sending my CV with my qualifications. And we just started talking over email and over phone. And then when the money came to hire me and the time was right and I finished my PhD, he gave me the job, so it's perfect.